So the other part that we're going to look at is other graphs that we're going to look at are rational functions. So rational functions are anything that can be written in this rational form where we have some sort of rational or polynomial in the numerator and polynomial in the denominator. There's all sorts of different types. We're just going to go over the main ones. As we get further into calculus, we will be introduced to even more complex ones. Okay, so here's a rational function. What we're often looking for rational functions are where the denominator is equal to 0. In this case here, however, the rational function is not equal to 0, so we end up with these graphs that kind of look like this. Okay, there's no vertical asymptote. So it's possible that there's no vertical asymptotes in some of these. But in the most part, that's what we're looking for. We're looking for where the denominator is equal to 0. So here are some more typical ones where the denominator is equal to 0. Okay, so when we look at a function that looks like this, we're looking for where the denominator is equal to 0. Okay, so if we were to factor this, the numerator is not factorable. In fact, the numerator doesn't have any zeros, so notice that this graph does not cross the x-axis at any point, and we end up being able to factor the denominator like that, and we end up with vertical asymptotes here and here at -3 and +3. Here we have the denominator at -1. There's a vertical asymptote here. Okay, again, that's the main thing we're looking for, but we also should be aware of this fact that there is a 0 at 0. So actually, in this case, it just kind of touches. So at x equals 0, y equals 0. Okay, so that's another feature that we should be aware of. Some of you may or may not have done this slant asymptote. We'll look at that. If you haven't done that, that's fine. We're going to look at it today. So some of the key points, the key pieces that we're looking for are vertical asymptotes and holes, and we're going to look for horizontal asymptotes and slant asymptotes. So I forgot to talk about horizontal asymptotes, but horizontal asymptotes are endpoint behavior. So as x gets really, really large, what's happening to this? Or the limit as x goes to infinity, this is equal to 1, and notice that there is a horizontal asymptote at 1. Okay, for this one here, as we let x go to infinity, notice that the limit as x goes to infinity, the denominator dominates, so it's going to go to 0. So these, as we go to positive and negative infinity, you can see that there's a horizontal asymptote at 0. When we talk about the slant asymptotes, this diagonal asymptote, horizontal asymptotes are endpoint behavior. So slant asymptotes actually fall in that same category. They're actually endpoint behavior. Holes and vertical asymptotes are local behavior. So to find those, we would use a local limit. So how do we find these graph these rational expressions? So the example I've given you here is 6x squared minus 2 over x squared plus 2. What does that look like? Well, this does not have a vertical asymptote. So what we want to look at is our the horizontal asymptote. And so the horizontal asymptote is an endpoint behavior. So we're going to look at what happens as x gets really, really big. Well, the -2 and the +2 essentially become insignificant. And we can just compare the ratio of the highest powers. Okay? In this case, the highest powers are equivalent. So we can say that as x gets really, really big in the positive direction, it's going to be equal to 6. Also, as x goes to negative, it's actually going to have the same asymptote. So we're looking for these endpoint behaviors. Now, we can graph this, and at this point, we don't necessarily have all the tools to be able to graph this, but we'll just graph what we know so far. We know that there's a horizontal asymptote at +6. Okay? If we solve this equation, okay, for the numerator, again, the numerator gives us 0. When the numerator is 0, the denominator is equal to 0. Or sorry, not the denominator. The equation is equal to 0, or f of x is equal to 0. So when I solve this, I get x equals plus minus square root 1/3. Okay, so I know I'm going to have zeros here and zeros here. I could also figure out the y-intercept by plugging in x is 0. So when x is 0, y is equal to -1. Okay? So this graph, this is what I know so far of this graph. from what I understand, it probably looks something like this, is what my guess would be. Okay, so we can look at this, draw it on Desmos, and take a look at this, okay, which I'll do in the next clip.